Hello dear students. Now in this video we are going to discuss the solutions of chemistry questions from KVPY paper for the SBSX stream in the year 2013. So as you know that this paper is divided into two halves, paper 1 and paper 2. And paper 1 every question is worth 1 marks and paper 2 it is 2 marks. So let's get started. So the first question is, among the following the set of isoelectronic ions is. Now as per the definition we know that isoelectronic ions are basically those which have same number of electrons. So they should be having same number of electrons. So if you say Na plus, sodium plus, it would have 10 electrons. If you say magnesium 2 plus, it will have also 10 electrons. If you have F minus, 10 electrons, and O2 minus, it will also be 10 electrons. So we can see that option number C is correct. Hence for this question answer is C. Next, for a zero order reaction with a rate constant, the slope of plot of reactant concentration against time is. Now we know for zero order reaction, let us say we have A goes to product, and if we write the rate equation, minus dA by dt is equal to k times, since order is 0, it will be 0. And if we integrate from initial to final limit, we get this expression. We know that AT is equal to A0 minus K0 into T. So it's basically a straight line decrease, as we can see from the integration that we have got, integrated expression that we have got. So the slope over here would be minus k. Hence answer for this question would be D. Next, the compound which reacts with excess bromine to produce 2,6,2,4,6 tribromophenol is. Now we know that when we talk about say salicylic acid, OH and COOH, so we can see over here that when we have a strong electrophile, for example we talk about bromine in water over here, so it is going to produce positive brominium ion over here. So we know that due to ipso effect, we know that OH is activating because it is plus R group, and COH is deactivating, it is minus R. So the dominance of OH substituent will be there, and the replacement would be happening ortho and para position to the plus R group. So normally we would expect that at ortho position to the OH group we will have bromine coming in and also para, but due to ipso effect even this COH is replaced by bromine. So answer for this question is C. The variation of solubilities of 4 different gases are given in a given solvent with a pressure at a constant temperature is shown in the plot. So there are 4 gases, G1, G2, G3 and G4. The gas with the highest value of Henry law constant. So on the y-axis we have plotted solubility and x-axis we have pressure. So from the Henry's law we know that pressure is equal to the mole fraction into Henry's constant. So clearly if we were to see that the solubility, if we measure in terms of mole fraction, that will be equal to 1 upon kH times P, which means the Henry constant will be inversely proportional to the slope. So one with the least slope will have the highest Henry constant. So we can see that that happens for G1 gas, and therefore answer for this question is D. Next, question number 4, it says ethyl acetate on reaction with the NH2 NHCO NH2 gives which molecule? Now understand, when we say ethyl acetate, so the group is CH3COO C2H5, and over here we have a semi carbazide, and we can see over here that the 2 nitrogens which have lone pair in conjugation to C double bond O will not be sufficiently nucleophilic. Therefore the nitrogen which is not in conjugation will be more nucleophilic and would be attacking this carbon of C double bond O. Right, so this is more nucleophilic because this lone pairs are always available and not in resonance. And therefore ethyl acetates react with this molecule to form what? So this attacks over here and this C2H5O minus gets relieved and ultimately we get answer as CH3CO, and this would be NH, and this would be NH. So from semicarbazide we have formed a semicarbazone. Okay, so answer for this question we can say is C. Question number 4, answer is C. Next, for the reaction A goes to NB, the concentration of A decreases from 0.06 to 0.03 mole per liter, and that of B rises from 0 to 0.06 mole per liter at equilibrium. The value of N and equilibrium constant for the reactions are. So clearly we can say that A goes to NB is given to us. At initial instant, A was 0.06 and B was not formed. At equilibrium, we see that A has decreased to 0.03, whereas B has increased to 0.06. So from here we can say the moles or the concentration decrease in A would be 0.03, and the concentration increase is 0.06 for B. That can only happen when N is equal to 2. So N will be equal to 2. Now the second part of the question, we have to calculate Kc. That will be concentration of B whole square upon concentration of A. So at equilibrium, concentration of B is 0.06, whole square of that upon 0.03. So if we solve, we get answer as 0.12. So combining, we get answer as A. Question number 6, answer is A. Question number 7, it says the reaction of ethyl methyl ketone with Cl2 in basic medium gives which of the major product. So when we say ethyl methyl ketone, so we have ethyl on one side and we have methyl on the other side. Now when we say Cl2 react in a basic medium, so we can say that two things are formed, NaCl plus NaOCl. In NaOCl, Cl is positive. What happens is this hydrogen, this alpha hydrogens are replaced by this positive chlorine, right? Now we will have to understand on which side the hydrogen is more likely to be replaced. So we can see over here that due to this additional methyl group which is having the plus I effect, so this hydrogen will not be relieved much, because you know, if H plus goes, it's a negative, and this positive I would increase the charge. So therefore this would not be, this side of the left hand side of alpha hydrogen will not be replaced, only the right hand side would be replaced. And therefore what happens is we get CH3, CH2, and this will be CO, and all the alpha hydrogen would be replaced on the other hand side, right? So this is what we get. This is actually a the haloform reaction. It is basically haloform reaction mechanism where alpha hydrogens are replaced by halonium ions. So answer for this question would be B. Next, the compound which readily tautomerize is. Now we know that tautomerism can happen when you have a acidic hydrogen. So we just have to see which hydrogen would be more acidic. So in A options, as we can see that we have a methylene group. So what happens because of this methylene group? So it is stabilized by resonance on both sides. Okay, and therefore this hydrogen is more likely to delocalize or move between two polyvalent atoms, which is tautomerism phenomena. So answer for this question would be A, acetoacetic ester. Question number 9. Hydrolysis of BCl3 gives X, which on treatment with sodium carbonate produces Y. So we say BCl3 on hydrolysis, it is going to give us H3BO3 plus HCl, and this H3BO3 on reaction with Na2CO3, it is basically Na2B4O7 plus CO2 plus 6H2O. So we can match and say that option is B. Question number 10. It says number of lone pair of xenon in XeF2 and XeF4. When we say xenon difluoride, xenon is a noble gas, so it will have 8 electrons in the outermost orbit, and out of which 2 will be involved in forming a covalent bond. So the steric factor over here, number of lone pair is 3, number of sigma bonds is 2, so this will be 5. Anyways, we need to just calculate the number of lone pairs. So we can see from here that number of lone pair is 3 for the first one. For XeF4, we will have 1, 2, 3, 4 electrons, and the remaining could form a covalent bond. So over here we can see that it has only 2 lone pair of electrons. So number of lone pair in the second one would be 2. So hence we can see for this question answer corresponds to C. Question number 11. The entropy change in the isothermal reversible expansion of 2 moles of an ideal gas from 10 to 100 liters at 300 Kelvin is. So we know that delta S has this formula nRT, or we can say nR ln V2 by V1. Now we know that V2 is V2 is 10 times V1. So we can say V2 by V1 is 10. So if we convert this into base log 10, so multiply by 2.303 and putting the value, we get answer as 38.3. So for this reversible isothermal expansion, the entropy change would be corresponding to answer number C. So for this question answer is C. Now it is worth mentioning that the definition of an entropy change is basically Q reversible upon that particular temperature. For an isothermal process, delta Q is delta U plus delta W, and this change in internal energy is 0 because the temperature is not changing. And the work done over here is minus 2.303 nRT log V2 by V1. So we put that in place of Q reversible divided by temperature, so we are getting this expression. So answer for this question is C. Next, question number 12. It says D-glucose upon treatment with bromine water. Now we know that bromine water is an oxidizing agent. So bromine water is an oxidizing agent which will convert what? It is going to convert the terminal, I mean the below CH2OH group to it remains same, CH2OH group remains same. However, the aldehyde group gets oxidized to carboxylic acid. So we can see that the answer would correspond to A option. Hence for this question answer A is correct. Question number 13. In a structure of borax, the number of boron atoms and BOB unit respectively are. So this is the structure of borax. We can see two types of borons. These are sp3 hybridized having a tetrahedral structure, and these two are sp2 hybridized. So clearly the number of boron atoms is 4, right? And we can say that number of BOB bonds, we can see 1, 2, 3, and then you have 4, and 1 in between, the bridge one, it is 5. So answer would be 4 and 5 respectively. Answer would be A. Next, the number of peptide bonds in the compound. Peptide bonds are basically CONH bond. So clearly we can see over here that CONH bond is observable over here. So this would be what? This would be a peptide bond. Now this is a part of this will be same, I mean this is C double bond ONH group is there, but then we have to remember then that when we say peptide bond, it is basically formed due to condensation of carboxylic acid and amines from the other side. So here the other molecule is hydrazine. So hydrazine, that is not considered as a peptide bond. Therefore answer for this question is only 1. Hence option number A is correct. Then for the isothermal reversible expansion of an ideal gas. So when we say isothermal, we can say delta U will be equal to 0. H we define as what? U plus PV. So delta H will be equal to delta U plus delta PV. Now clearly for the ideal gas, delta PV, we know PV is equal to nRT. So delta PV will be equal to nR delta T, and delta T temperature change is not there. Delta U is 0, delta PV is 0, therefore delta H will also be 0. So for this question answer is C. Next, if the angle of incidence of X-ray of wavelength 3 angstrom which produces a second order diffracted beam from 100 plane in a simple cubic with the interlayer spacing of A is equal to 6 angstrom, is 30 degrees, the angle of incidence that produces the first order diffracted beam from 200 plane is. So these are basically Miller indices, and when we say Miller indices, it is just reciprocal of their intercept. So HKL, these are basically the intercept, and reciprocal of that is the Miller indices 100. So if you have to imagine a 100 plane, it would mean what? The reciprocal of intercepts. So 100 plane would mean if A, B, C are the intercept, 1 upon A is to 1 upon B is to 1 upon C would be equal to 1 is to 0 is to 0, which means B and C should be infinity and A should be 1, right? So if I say this is x-axis, this is y-axis, and this is z-axis, right? A should be 1, which means this plane at the distance of A would be what? This would be this vertical plane is represented by 100. Similarly, 200 would be a plane which is just at a half distance A by 2. Okay, so this question is based on the Bragg's law. The wavelength of X-ray is given as what? It is given as 3 angstroms. Now the lattice constant A is given as 6 angstrom, right? The interlayer spacing A is given, right? And HKL for the plane that we are supposed to find the angle of incidence is 200 plane. HKL is this. So once we have to find the distance from the Bragg's law, we know 2d sine theta is equal to n lambda. So how do I find the distance between the two layers? That will be nothing but A upon under root of h square plus k square plus l square. Right, so that comes out to be putting the values 200, the spacing in that would be equal to 6 upon root 4 will be equal to 3. Now one thing to understand over here is when you have 100 spacing, 100 plane, that would mean what? That would mean that this would be this plane which is in the YZ plane. This is the YZ plane perpendicular to the x-axis at a distance A. So the distance between two subsequent planes would also be A in that case, that is 100 plane. However, when you say 200 plane, the distance would be just half. So it would be the plane in the YZ plane perpendicular to x-axis, and these planes are in having a distance between them as A by 2. So the distance over here would be the actual spacing was A by 2, which is equal to 3. Now putting this 2d sine theta is equal to n lambda, we get sine theta is equal to 1 by 2. So theta would be equal to 30. Right. Also one thing we should know over here, that since the planes are parallel, we don't have to do any of these calculations, and we know that if the planes are parallel for the same incidence, I mean the same ray, the angle of incidence on parallel we can say surfaces is equal. Therefore from there also we can say angle should be equal to 30, and there is no need for solving also. So for this question answer is C. Now for question number 17, it says number of ion produced by dissolution of a complex having a empirical formula which is COCl3 4NH3. So over here if we can see that the coordination number of cobalt, this is CO is cobalt, not carbon monoxide, C small o. So that coordination number of cobalt is 6. So it has to be NH3 4 times Cl2, and therefore 1 Cl would be outside, right? So ammonia has to be in the coordination sphere, right? So we can see over here the coordination number of this particular molecule is this cobalt is 6, and therefore when it ionizes, it is going to give us 2 ions only. So CONH3 4 times Cl2 plus, this is the cationic part, and we have a Cl minus. So in all we get only 2 ions. Hence for this question answer should be B. Next, question number 18. The spin only magnetic moment of this complex and FeF3 minus in Bohr magnetons are this. Now we know that NH3 is what? NH3 is a strong field ligand, whereas fluorine is a weak field ligand. And in both the configurations what we have Fe3 plus. Fe3 plus is 3d5. So with ammonia the pairing is going to happen right? Whereas with the F minus, pairing is not going to happen. So when you have F minus fluoride ion as a ligand, number of unpaired electrons will be 5, right? And therefore the magnetic moment, which is calculated as under root of n plus 2, that will be equal to nearly 5.92. Now for the case of ammonia, it will be paired. So when you pair 5 electrons, so it would be number of unpaired electrons will be 1. So under root of 1 into 3, that will correspond to 1.73. So answer for this question would be, we can say that for ammonia it would be 1.73, and for F minus it has to be 5.92. For this question, answer is C. 18, answer is C. Question number 19. The order of SN1 reactivity in an aqueous acetic acid solution for the compound is. Now we know that the rate of SN1 reaction is directly proportional to stability of the carbocation. So we just have to check the stability of the carbocation. So let us remove halide from all of them and create a carbocation. So this goes, this and this. So clearly in the third one we have a 3 degree carbocation. Right, in the second one we have 1 degree carbocation, and in the first one we have 1 degree, but that is resonance is stabilized. So clearly we can see that the stability order over here. Now because of this C double bond O, it will also have a minus I effect, and therefore this bond is strengthened, and Cl minus would not leave out very easily, and formation of carbocation would be bit difficult. So the order of SN1 reactivity will be proportional to the ease with which we can form a carbocation A, and B, it also depends upon the stability of the carbocation formed. Hence for this question we can see option number C is correct. Question number 20. In a ionic compound is formed between a metal M and a non-metal Y, if metal M occupies half the octahedral voids in the cubic close pack arrangement formed by Y, the chemical formula for the ionic compound would be. So since Y is cubic close packed, so we can say that it is in FCC configuration. So the effective number would be it would be 8 into 1 by 8 for the corners which are there, and 6 into 1 by 2. So effective number of Y per molecule will be equal to 4. Whereas when we say octahedral voids, we know that the location of octahedral voids are where? It is at the center of the cube and also the edge centers. So the effective we can say for this M metal is going to occupy half of that. Effective octahedral voids would contribute 4, but since they are occupied only half, it is going to contribute 2. So the formula should be M2Y4, and empirically it should be MY2. Hence for this question, answer is B. Now let us see part 2 of the question paper and the questions which were asked in the KVPY SBSX stream section in the year 2013. Question number 1. The major product obtained in reaction of aniline with acetic acid, acetic anhydride. So we know that aniline is basic in nature, whereas on the other hand acetic anhydride, in that this acetyl group CH3 acetate group is a good leaving group, so it is going to leave taking away the electrons, so it creates a acylium ion and that attacks over here. So basically answer for this question would be corresponding to A. For this question answer is A. Next, the maximum number of isomers that can result from monobromination of 2-methyl-2-pentene. So when we say 2-methyl-2-pentene, the structure of the molecule would be like this. And NBS, when we say, is basically used for brominating at the allylic position. So allylic positions are what? Carbon, double bond carbon, adjacent to this carbon, these are allylic positions. So we can see that these carbons and these carbons are likely to be replaced. So let us see how many compounds will be formed. So if this particular carbon is replaced, then we can see that we can have two possibilities. It can be cis and trans possibility over here, right? And the second possibility, when this side is replaced by bromine, right? So in that case, there is no geometrical isomerism possibility, but we can see that this is a asymmetric carbon, so we'll have a DL configuration happening over here, right? Note that these two replacements are same, these two are identical, and therefore we have to consider only one of the two. So when these are replaced, we can have a geometrical isomerism, and when this hydrogen is replaced, then we can have the enantiomeric pair. So total would be 4. Answer would be D for this particular question. Next, compound X C7H9N reacts with benzene sulfonyl chloride to give Y, which is insoluble in alkali. Now we know that this happens only for the case of secondary amine. For the case of primary amine, we do get an intermediate compound, but that still have an acidic hydrogen, so it does react with the alkali. That is for the primary amine. For secondary amine, that is not going to happen. So we just have to identify a secondary amine over here. So answer would correspond to A. Right? Then question number 4. In 108 grams of water, 18 gram of non-volatile compound is dissolved. At 100 degrees centigrade, the vapor pressure of solution is 750 mm Hg. Assuming the compound do not undergo association or dissociation, the molar mass of compound is. So we know over here that this is based on relative lowering of vapor pressure. Delta P upon P naught will be proportional to mole fractions of solute, right? And if it is a very dilute solution, we can say it is number of moles of solute upon number of moles of solvent, right? So putting the value, the normal pressure would be 760 millimeter, but what we are observing is 750, so there is a depression of 10 millimeter Hg. So depression in we can say vapor pressure, right, that would be lowering in vapor pressure would be 10 upon P naught, which is the standard value. 60 should be equal to moles of solute, which is let us say 18, and we have to find the molecular mass, consider that to be M, upon the moles of solvent, that is we can say 108 divided by we can say 18. So on solving, M comes out to be 228. So answer for this question is D. Question number 5. The standard electrode potential for zinc is minus 0.76 volt, and that for copper is 0.34. This is basically a galvanic cell. The EMF and the free energy change respectively for this Daniell cell is. So we know that EMF of a cell would be equal to reduction potential of cathode minus reduction potential of anode. Right, so zinc will be acting like a anode and copper will be acting like a cathode. So putting the value, this will be 0.34 minus 0.76. So the net resultant would be 1.1 volt. Right, and delta G naught, that is equal to minus NFE naught. So putting the value, N factor over here is 2, F is 96500 into E, which is 1.1. So answer comes out to be minus 213 volt. So for this question, answer number B is correct. Then question number 6. Consider the equilibrium 1 and 2 with the equilibrium constant K1 and K2. Now we know that equilibrium constant representation would depend upon the stoichiometry of the reaction. So for the first reaction, we can see that the equilibrium constant K1 will have an expression of this will be concentration of SO3 divided by concentration of SO2 into concentration of O2 raised to power 1 by 2. And for the second reaction, it will be concentration of SO2 whole square into O2 upon concentration of SO3 whole square. So basically for any reaction, equilibrium constant is the we can say ratio of the active mass of the product over reactant as per how we are representing the reaction. So if you were to see that K2 is in fact a negative reciprocal. If you take reciprocal of K1 and then square it, the expression that you get is equal to K2. Therefore for this question, we can say that answer is B. Options are not mentioned over here, but the option number B was K2 is equal to 1 by K1 square. Okay. Next, aqueous solution of metallic nitrate X reacts with NH4OH to form Y, which dissolves in excess NH4OH. The resulting complex is reduced by acetaldehyde to deposit the metal X and Y respectively R. So that is basically silver nitrate. So we have AgNO3 will react with NH4OH to form a we can say it will initially form silver hydroxide, which will dissolve in excess NH4OH to form a complex. Right, so a complex formation would take place. So this is basically, if you remember, is a Tollens reagent, and Tollens reagent does oxidize acetaldehyde. So the final answer over here would be CH3CHO will be oxidized to CH3COH, and that is done by mild oxidizing agent like Tollens reagent. So you can see over here that for this question particularly, answer is C. For question number 7, answer is C. Then question number 8, the density of equivalent weight of metal are 10.5. I think density and equivalent weight of metals are 10.5 and 100 respectively. The time required for a current of 3 ampere to deposit a 0.005 millimeter thick layer of same metal on an area of 80 centimeter square is closest to. So we know that W is equal to Z into I into T. Right, so W is equal to, and Z is what? Electrochemical equivalent, that is E upon 96500 into I into T. Right, and the density is given to us, but how to calculate mass or weight over there? So we know that mass will be equal to density into volume, and volume would be what? That will be area into the height to which this is deposited. So if I put the value density as what? This is 10.5, area of cross section is 80, and the height is 5 into 10 raised to power minus 4. So that will be, the mass would be 42 into 10 raised to power minus 2 in grams. So this is what I put in this particular formula. So we have 42 into 10 raised to power minus 2 is equal to, this is 100 upon 96500 into I, which is current is 3 into time T. So on solving, T is equal to 135 second. So for this question, answer is B. Next, question number 9. The amount of Na2S2O3.5H2O required to completely reduce 100 ml of 0.25 normal iodine solution is. So we can use the law of equivalence, where we can say N1V1 is equal to N2V2. So equivalence of hypo required, equivalence of hypo is Na2S2O3 required would be equal to equivalent of iodine. That is how much? That is 100 into 0.25. Right, so the milli equivalents, if I say milli equivalents, so that will be 25 milli equivalents of that. Right, now clearly for this titration, which is Na2S2O3 plus I2 giving us sodium tetrathionate Na2S4O6 plus NaI, we will see that N factor over here on these two sulfur, the charge is plus 4, and not 4 but 2 sulfur over here, charge is plus 5. So N factor for this would be equal to 1. Right, therefore we can say moles of hypo solution, which is required, would be number of equivalents divided by 1. So that will also be equal to what? That will be 25 millimoles. Right, so this will be moles of hypo would be 25 into 10 raised to power minus 3. Right, and therefore weight of this would be number of moles 25 into 10 raised to power minus 3 into its weight. The molecular weight of Na2S2O3 is 248. So multiply by 248 and answer comes out to be 6.2 grams. So answer for this particular question is A. Next, 10. In an aqueous solution, cobalt H2O6 2 plus reacts with molecular oxygen in the presence of excess liquor NH3 to form a new complex Y. The number of unpaired electrons in X and Y are respectively. So initially we have cobalt H2O6 times 2 plus reaction with 6 NH3 gives us what? It gives us cobalt NH3 6 times, this is 2 plus, and then when you have O2 is passed through as molecular, the oxidation happens, so cobalt raises from plus to state to +3 state over here. So cobalt is oxidized. So if you see for cobalt, this complex number of unpaired electrons is 3, and therefore the magnetic moment will be 3.9. For this particular complex, it is diamagnetic, no unpaired electrons, right? And therefore magnetic moment will be 0. So what they're saying is number of unpaired electrons in X and Y. So it will be 3 and 0 respectively. Answer for this question would be B. Thanks for watching this video. Here we have discussed the solution of KVPY 2013 SBSX stream paper. Right, and I'll be posting for the further, more years question paper solution, particularly chemistry, right, in the next videos. Thanks for watching it. Thank you.